So I'm Richard Boyd, CEO of Invizius. So fascinating talk from René. I'd like to move the discussion now to Streptococcus pneumoniae. So Streptococcus is a very successful pathogenic microbe. It's the leading cause of pneumonia and bacterial meningitis. It's responsible for the deaths of millions of people worldwide every year. And the reason for its success is that Streptococcus has found a way of hiding from the human immune system, and that allows it to move around the patient undetected by the immune system in the blood. So what we're doing at Invizius is we're taking the invisibility cloak from Streptococcus, and we're applying that to solve a very long-standing, unmet need, unsolved problem in extracorporeal treatments. And that will be very much to the benefit of patient outcomes. So we're a spin-off from Edinburgh University. Research at Edinburgh looking into the way in which pathogenic microbes like Streptococcus pneumoniae evade the human immune system. And we are very lucky to have benefited from over £500,000 worth of translational funding from Scottish Enterprise, which allowed us to move from a research project to a well-defined business opportunity with early establishment of industrial collaborations. So we spun out from the university after 3 years of translational work in April last year with £500,000 from Mercia Technologies. And Mercia remains our lead investor. And so we, not unsurprisingly, are looking for investors. That's why we're here. And we're looking for co-investors to come in with Mercia in future rounds. So our next round is in the middle of this year, will be for somewhere south of £1 million. And whereas with the funding we currently have, which has been focused on finalizing our product design and establishing feasibility of manufacturing, we're going to be using our next round of funding to ensure that we are going to pass preclinicals and we are going to have a product that actually works. And one of the nice things about working in extracorporeal circuits is that we can test this with human blood without actually going to a clinical trial. So we hope to present as a result to investors, as a result of this work, compelling evidence for why they should join in on a Series A round in 2020. So really this is pre-publicity for a 2020 round, Series A, which will be multi-million pounds and will take us to a first-in-man trial. So what do I mean by extracorporeal treatments? I hear you ask. These are listed up here. So hemodialysis, I'm sure most people are familiar with. If you have chronic kidney failure, dialysis cleans your blood with thrice weekly dialysis sessions. Continuous renal replacement is a similar thing, but for patients with acute renal failure in intensive care. ECMO is a procedure that essentially gives your heart and lungs a rest while you're in intensive care, so it provides oxygenation and circulation support, and is closely related to cardiopulmonary bypass, which is a procedure used to maintain circulation and oxygenation of the blood during open heart surgery, i.e. when the heart is no longer beating. So what is the problem with extracorporeal circuits? Well, in all cases, what you're doing is you're pumping the patient's entire blood supply out of the patient and through a machine, a man-made machine made from man-made materials. And the immune system in the blood recognizes that this is foreign. It's a foreign body. And in fact, it's a very large foreign body. So take dialysis, for example. The filter that your blood is passed through has an effective surface area of 2 square meters. The oxygenator in a cardiopulmonary bypass has a surface area of 3 or 4 square meters. So this is a very large foreign body. And the immune system reacts to that. So there is an immune response. And as a result of that immune response, there is a systemic inflammation in the patient. And as a result of that, you see a whole host, potentially, of downstream problems or complications for the patient. So I've listed them there: cardiovascular, neurological, nephrological, et cetera, Which ones you're talking about depend on which extracorporeal treatment you're concerned with. Perhaps the most sobering of the extracorporeal treatments, and perhaps where the unmet need is greatest, is in hemodialysis. So patients are connected to this large foreign body 3 times a week for 4 hours. And what they're getting through this inflammatory response is a chronic acute insult to their cardiovascular system. So there is damage to the cardiovascular system each time they go on to dialysis. And what you see is that over 50% of patients actually die from cardiovascular complications. Those complications cost a lot of money. And most shocking of all is that life expectancy on dialysis is slashed by 2/3, which is an extraordinarily poor outcome. And there has been a paucity of innovation in terms of materials science, and means of attenuating this issue. And these statistics have really not changed in 25 years or more. Okay? So, what are we going to do about it? Well, I mentioned Streptococcus pneumoniae. That's the bacterium on the left-hand side. So what the research at Edinburgh University did was identify a protein on the cell surface, on the surface of the Streptococcus pneumoniae, which binds irreversibly factor H from the patient's blood. And factor H is a downregulator of the innate immune system. And this protein, not only does it bind factor H onto the surface of the bacterium, it actually supercharges it. It makes it 5 to 10 times more potent as a downregulator of the innate immune system. So we've identified that. We have a mechanism of action patent on that interaction with factor H. And we've modified the protein from the bacterial cell surface to make it sticky. Okay, so it will stick to the blood contact surface of the extracorporeal circuit. All these circuits, before you hook the patient up, have to be primed. And priming right now is done, in most cases, with a simple saline solution. Right? And the objective is to get all the air out, remove any manufacturing residues, wet all the surfaces. And very simply, what we're doing is adding our H-guard protein to the simple saline solution. And you go through the same priming process, same priming procedure as before, but it leaves a coating of this invisibility cloak across the entire blood contact surface, thus shutting down the immune response and the ensuing inflammation. This is actually a medical device. It's a class 3 medical device with an ancillary medicinal substance to give it its full regulatory status. And it's a consumable. So this is, in terms of the business model, it's kind of it's the razor blade to somebody else's razor. So the razor is the consumables sold for the extracorporeal circuit, and we're selling an accessory to that, which is the priming solution. A little bit of data to show that it works. So this is an assay, a C3b deposition assay. It is basically, this is the initiation of the innate immune system on the reacting with a foreign surface, right? So you see on an uncoated surface, there is C3b deposition, and that marks the initiation of the innate immune response. Coated with H-guard, pretty much no reaction. And this is on a polystyrene surface, so it's highly reactive to the immune system. So we can actually shut down the immune response on what would otherwise be a highly reactive surface. A little bit more pictorially, you can see some stainless steel strips soaked in blood. And it's worth saying that this is primarily an anti-inflammatory, but it's also an anticoagulant, because the innate immune system actually has pathways to coagulation as well. And the graphic on the left-hand side is really tracking the innate immune response, which is much reduced. The existing coating technology, which is designed to ameliorate this reaction of patient's blood, are heparinized coatings, heparin coatings. They've been around for 30+ years. And the world has really not moved on all that time. There are many variants of heparin, but it's basically the same sort of approach. And if you compare heparin with H-guard, the analogy we like to draw, the simplistic analogy is, if you're leaving your house and it's very cold weather and there's a flooding risk from burst pipes, do you want to stock up on mops and buckets in case a flood occurs, and you use those mops and buckets to clear up the flood as it's occurring? Or do you just want to shut the water off altogether at the stopcock? So H-guard is about shutting off the immune response before it happens. Heparin is about dealing with the downstream after effects, if you will. And heparin is primarily an anticoagulant, whereas H-guard is primarily an anti-inflammatory plus an anticoagulant. And that's very important. So, with heparin, the inflammation-related complications persist. So despite this innovation 30 years ago, this problem still exists. So the market opportunity, we're developing our device, our product, is being developed to be used in any of these applications. And right now, we're not entirely sure which of these applications we're going to pursue first. And there are pros and cons of each of them. But individually, they are all very large market opportunities. And as I say, the device that we're developing is going to be common to all of them. We started working with dialysis and cardiopulmonary bypass equipment manufacturers almost 4 years ago. And these collaborations still exist and have been extremely helpful in terms of directing our technical work. And obviously, ultimately, from an investor standpoint, we're looking to exit the company to companies like this. So confidentiality, unfortunately, doesn't allow me to say which of these companies we're working with, but they may be on that slide. In terms of our team, we are still very much building the team. I come from my last business was a cardiovascular implant business, which I took through various rounds of funding, trade sale. Our chairman, Magnus Nicholson, is a very highly experienced life science executive, and so on and so forth. We are actively recruiting to ready our team and the business for a Series A round next year. And we already have very good connections with with the local NHS and clinicians. So I think that's about it.